All right, we're live. Okay, I'm calling this reading chair.
Okay.
So we're reading to Grandma. It's a promise I made her at Kwanzaa,
Sure did.
and Lyric is helping Grandma hold the book.
Yeah.
So she had a lot of options, and we went with Grandma chose the brain. Okay,
We're gonna start off on the right.
so let's start off on the brain.
Mm-hmm.
Okay, can everyone see?
Mm-hmm.
All right. The human brain is the most complex entity we know of. It contains at least 90 billion neurons, nerve cells. Each of these is a complex information processing device in its own right and interacts with about 1,000 other neurons. Understanding this degree of complexity is a daunting task.
Mm-hmm.
Our understanding of the human brain is still in its infancy. The identification of the neuron as the basic building block of the brain occurred only 100 years ago. At first, progress depended on the study of damaged brains. It is only in the last 25 years that it has become possible to see brain structure and function in healthy volunteers. The remarkably detailed images that emerge from brain scanners with their brightly detailed images that emerge from, with their brightly colored blobs have had a dramatic impact. Human brains have become the image of choice for the media, attached to articles about what our brains can teach us or contours of the mind. Brain research is beginning to attract big money. The Brain Activity Map project is expected to receive $3 billion from the US government over the next 10 years. The hope is that the hope is that investigating the human brain in exquisite detail will have a similar payoff to that achieved by the Human Genome Project and will lead to the progress in understanding mental disorders such as autism and schizophrenia.
Mm-hmm.
One of the most exciting features of research on the human brain is that we confront deep philosophical questions. Minds depend on minds depend on brains. Without brains, we could not think or feel or imagine, but we still feel uncomfortable with this identity. Am I simply the product of electrical activity in my brain? How can subjective experience emerge from brain activity? Our theories about how brains work remain very primitive. Some people think that an some people think that an insoluble conundrum arises because the human brain is trying to understand itself. Surely something complex can only be understood by something even more complex. I believe that this problem is more apparent than real. Here's why. One of the glories of the human brain is that it enables us to share our thoughts. Our understanding is built on the thinking of our predecessors as well as our contemporaries and far transcends the abilities of any single brain. We pay too little attention to these effects of culture and collaboration. Consider another highly social animal, the bee. The brain of a bee weighs 1 milligram and contains a mere million neurons. Yet this tiny brain enables bees to learn about the world and communicate using their waggle dance. Even more impressive is what bees can achieve through collaboration. From the reports of scouts, a swarm of bees can make a group decision about the best site for a new nest. Recent studies suggest that the way the bees interact to make decisions closely resembles the way neurons in the human brain interact to make decisions. This comparison gives us a feel for the dramatically enhanced abilities of the human brain compared with the bee brain. but it also instills in me a sense of wonder about what humans can achieve as a group. A group of bees working together can achieve abilities resembling those of a single human brain. Imagine an entity containing the power of multiple interacting human brains. We create such a system whenever we interact. And the best example of the power of such a system comes from the practice of science. It is through the practice of science that we will be able to unravel the mysteries of the brain. This book shows how exciting this journey will be.
Isn't that something? And you can see a beehive,
Yeah.
how they work together.
Yeah, they do.
Yeah.
You want to turn the page?
They sure work together. It's hard to beat them too. Because they keep working out.
Okay, now I'm reading that was the forward. Now I'm going to read the introduction. Understanding how the brain works is one of our greatest scientific quests. The challenge is quite different from other frontiers in science. Unlike the bizarre world of the very small, in which quantum mechanical particles can exist and not exist at the same time, or the mind-boggling expanses of time and space conjured up in astronomy, the human brain is in one sense an everyday object. It is about the size and shape of a cauliflower, weighs about 3 pounds, and has a texture like tofu. It is the complexity of the brain that makes it so remarkable and difficult to fathom. There are so many connections in the average adult human brain that if you counted one each second, it would take you more than 3 million years to finish. Faced with such a daunting prospect, it might seem as well to give up and do some gardening instead. But the brain cannot be ignored. As we live longer, more and more of us are experiencing or will experience neurodegenerative conditions such as Alzheimer's disease and the incident of psychiatric illness, such as depression and schizophrenia, is also on the rise. Better treatments for these conditions depend on a better understanding of the brain's intrinsic networks. More fundamentally, the brain draws us in because it defines who we are. It is much more than just a machine to think with. Hippocrates, the father of Western medicine, recognized this long ago. Quote, men should know that from nothing else but the brain comes joys, delights, laughter, and jest, and sorrows, grief, despondency, and lamentations. More recent, Francis Crick, one of the major biologists of our time, echoed the same idea. Quote, you, your joys and your sorrows, your memories and your ambitions, your sense of personal identity and free will are in fact no more than the behavior of a vast assembly of nerve cells and their associated molecules. And perhaps less controversially, but just as important, the brain is also responsible for the way we perceive the world and how we behave within it. So to understand the brain is to understand our own selves and our place in society and in nature.
That's important that the brain feel. Are you gonna turn that page? That's the brain.
Okay. But how to begin? From humble beginnings, neuroscience is now a vast enterprise involving scientists from many different disciplines in almost every country in the world. The annual meeting of the Society for Neuroscience attracts more than 20,000 and sometimes more than 30,000 brain scientists. No single person, however capacious their brain, could possibly keep track of such an enormous and fast moving field. Fortunately, as in any area of science, Underlying all this complexity are some key ideas to help us get by. Here's where this book can help.
Oh my goodness.
How the book works.
Right.
Within the following pages, leading neuroscientists and science writers will take you on a tour of 50 of the most exciting ideas in modern brain science, using simple, plain English. To start with, in Building the Brain, we will learn about the basic components and design of the brain, and trace its history from birth and before, and through evolution. Brain theories will introduce some of the most promising ideas about how the brain's many billions of nerve cells, neurons, work together. Mapping the brain will show how new technologies are enabling us to chart the brain's intricate structure and activity patterns. Then, in consequences or consciousness, we tackle the still mysterious relationship between the brain and conscious experience. How does the buzzing of neurons transform into the subjective experience of being you? Here, now, reading these words. In the following chapters, Perception and Action, and Cognition and Emotion, we will explore how the brain enables these important functions both with and without consciousness. Finally, in the last chapter, The Changing Brain, we will explore some recent ideas about how the brain changes its structure and function throughout life in both health and in disease. Approach the book however you like. Read it in order or dip in and out. Each of these 50 ideas is condensed into a concise, accessible, and engaging 30-second neuroscience. To get the main message across, there is also a 3-second brainwave and a 3-minute brainstorm. Provide some extra food for thought on each topic. There are helpful glossaries summarizing the most important terms used in each chapter, as well as biographies of key scientists who helped make neuroscience what it is today. Above all, I hope to convey that the science of the brain is just getting into its stride. These are exciting times, and it's time to put the old gray matter through its paces. Lyric?
Those brains.
I need you to turn the page.
Brains.
Okay, building the brain.
Build it.
Okay, turn the page again.
Build it.
Ooh. Okay, this is the glossary. So you can turn the page right now. We'll come back to these words
I ain't gonna be over brains.
if we need them. All right. Neurons and glial cells. All right, you ready to learn about neurons and glial cells?
I guess so.
All right. Your neurons, your marbles if you prefer, are the information processing cells of your brain. You have between 90 and 100 billion of them.
Wow.
Yet not one of them has any idea who you are. But somehow, by chattering among themselves across networks of billions of interconnections, neurons conjure up your self-awareness. Neurons receive messages from other neurons on their cell body and its short extensions called dendrites and at specialized structures called synapses. I've heard of those before. Messages are sent to other neurons via long, slender fibers called axons. That was in the glossary. We'll read about it later. Encoded patterns of electrical spikes, nerve impulses. Each impulse is about 0.1 volt and lasts 1 to 2,000 of a second, hurling along axons at up to 300 miles per hour. Arriving at the synapses, impulses trigger the release of signaling chemicals called neurotransmitters. These alter the pattern of spikes generated by the receiving neuron, and that is basically how the brain works. Well, not quite. Neurons work properly only if
You don't have
bathed
to hold that.
only if bathed in the number in the in, I'm sorry, only if bathed in the right blend of chemicals. Glial cells, which outnumber neurons 50 to 1, maintain this condition. They help neurons wire together in the developing brain, nurture them in the adult brain, insulate axons, mop up dead cells, recycle used neurotransmitters, and protect the brain from infection. They are unsung heroes. They are the unsung heroes of the brain story. Lyric. Get that picture. Okay, we're gonna do neuroreceptors and then we'll go to Fernand. Okay, Grandma?
Now all these is
Yeah, that's like a representation. If you can't see it, it's a bunch of little like workers, and that's just showing you all the things in your brain. Yeah.
How your brains is busy, huh?
Lyric, you want to read the title of the what it's called? It's neurotransmitters and receptors.
Neurotransmitters and receptors.
You want to go read it too, Grandma?
It's a greater seconds. What is that?
Neuroscience.
Neuroscience.
Okay. Neurotransmitters convey signals between neurons, briefly exciting or inhibiting their electrical activity. They are released when nerve impulses arrive at synapses. They range from very small molecules to medium compounds to giant molecules called peptides. They are stored in tiny spheres called synaptic vessels. Impulses cause the vessels to release their contents into the synaptic gap between transmitting and receiving neurons. Released neurotransmitters act by binding to receptor proteins, each of which is turned to just one neurotransmitter type. These are scores of neurotransmitters and even more receptors. Why so many? After all, if neurotransmitters mediate just two simple functions, excitation and inhibition, surely two transmitters and their receptors is enough. Things are not so simple. Many neurotransmitters do not trigger fast excitation or inhibition, but indicate quite slow metabolic processes in neurons, causing lasting changes in the strength of synaptic connections. Neurotransmitters can also initiate the switching on and off of important genes, which can cause long-term change in neuronal and synaptic properties. Are these the changes in the brain on which memories depend? Probably, but we are far from a complete understanding of the brain's complex chemical language. Okay, so now we're gonna put.
The brains is busy.
Isn't it?
Wow.
Where's our bookmark?
Yeah. That's actually it.
Okay, Lyric, you put the bookmark right here to save our place. And then Grandma, you slide it up so that the red part's shown.
Yeah.
Alright, and that we'll use that to save our place.
Oh, so that's the book. Brain.
Yeah, brain.
That's something. Brains, huh?
Alright, now we're gonna read Ferdinand. The story of Ferdinand.
Okay.
Have you ever heard of this, Grandma? No?
I don't care.
I can tell it has a horse.
You have.
You heard of it?
No, I can tell it has a horse.
A horse? Oh, okay. Well, let's find out. All right, Lyric, you hold the book right there. All right, now Lyric, you read that part. Once
Once
upon
upon
turn the page.
There was a little blue
Bull.
bull and his
Name.
was
Ferdinand.
Oh, the bull named
And then that's the
Ferdinand.
picture of him.
Yeah, that's old Ferdinand.
Okay, he's looking at a flower, and the
Yeah.
bee is on the flower.
Yeah, he's trying to. Yes, yeah.
I'm not for butterfly. Sorry.
Butterfly.
I was thinking about the bee because of the brain.
Oh, no.
All right, turn the page, man.
Yes, butterfly. Okay.
Okay. Go ahead.
all the
Other
other little
bulls
bulls he
live
lived
would
would run and jump
That's but,
and
but,
their
their
heads
heads
together.
together.
And then all the bulls are running and jumping and butting their heads together. Okay, turn the page, right?
Okay.
And then go ahead.
No,
But not
but not
What's the old bull
for
name?
now.
Ferdinand.
Ferdinand. That's old Ferdinand.
So Ferdinand is by himself while all the other bulls
Look
are
lonesome, don't he?
running
Look
and
lonely.
bumping.
Yeah, look, Ferdinand look lonely too by himself.
Okay, turn the page, right?
They like to
Sit,
sit
just,
just
Quietly.
quietly and
smell.
smell the
Flower.
flowers.
You see, you're lonely, huh? Oh,
No, he liked to sit.
Oh,
just
he wanna be
quietly and
alone,
stuff.
huh?
See him how happy he is
Yeah,
sitting by the
Ferdinand.
flowers.
Yeah,
It's
well,
like he's eating
you want to be
flowers,
by
kind of.
himself.
Go ahead and turn the page.
It's like he's eating a flower, kind of.
Uh-huh.
Okay, go ahead.
He had a
Favorite
favorite
spot.
out in the
Pasture
pasture
under
a
cork
cork
tree.
tree.
And then you
His little
see,
favorite spot.
yeah, that's his little favorite spot. You see it?
Uh-huh.
And the TV has its wings up the
Yeah, on his little spot.
That's maybe too hot.
Yeah, look at it. He just is comfortable.
Go ahead, man.
It was his favorite tree, and he
Wood.
would sit in
It's
its shade all
day.
all day and
Smell.
smell the flower.
Yes, yes.
And he is sitting, and you see the other bulls are running around butting heads.
And
I go over there.
And he
What's
just
that?
sitting there doing his thing.
Yeah.
Isn't that something?
Okay, you gonna go ahead and turn the page.
Oh, Ferdinand.
Sometimes
Sometimes his
mother
mother
who
who was
a
a
cow
cow
would
Uh-uh.
worry
worry
about
about him.
You see, she worried about him.
She was
afraid
afraid he would be
lonesome
lonesome
all
all day
by
all by himself.
Himself.
and then you see his mom just worried about it.
Yeah,
You see him sitting under his
yeah,
shade.
he ain't worried about nothing. Ah. But she's talking to him now.
Why
Why
don't
don't you run and play with the other little
bulls
boys
Mhm.
and
skip?
skip and
But
butt your head. She
would
would
say,
say, be,
but
but
Well,
For
Ferdinand.
Ferdinand,
Ferdinand
yeah, Ferdinand,
would
shake
shake his head. I like
it
it
better.
better here
Where
where I can
sit
sit
just
just
quietly,
quietly and
smile.
smell the flowers.
And you see him telling his mom, I don't want to go. You see his mom telling him, why don't you run and play with the other little bulls?
Just shaking his
He
head
trying to
like his
convince her
head
that he
like
happy,
his
yeah.
hoof is out.
Yeah, I'm happy with Matt.
His mother
Yes, saw
saw that he
was
was not
lonesome
lonesome and
because
because
She.
he
That's right.
was
and understanding
an understanding
mother,
mother,
even though
though
she
she was a cow, she
let
let him
Understanding nothing.
just
just sit there
there
and be
happy
happy
he was happy just being alone. He was alone, huh?
His mom understood him.
Yeah. And he just sat there and be alone. That's nice.
As the
Years
years went by,
Ferdinand
Ferdinand
grew
grew and
same word
grew
until
until he was
very
very big and strong.
okay. So now Ferdinand went from a small little bull.
He a big,
He's a big bull.
not big. It's like you done gathered up on him.
All the
Other
other bulls
who
who he
had
had
grown
grown up
with
with him in the
same
same
pasture
pasture
Fight, fight, fight.
would
fight
fight
each
each
other
other
And stick.
all
all the
day.
day.
Yeah.
That
Day
they would
but
but
each
each
other
other
Uh-huh.
and
and
stick
stick
What's he home?
each
each other with
their
their
horns. What
what
they
they
wanted
wanted
most
most of
all
all was to be
picked
picked to
fight
fight at the
bull
bull
fight
fight in
Madrid.
Madrid.
They was trying to show that it was bad, huh?
Yeah, and then you
So
see
they
a
could be
sign that says bullfight at the stadium in Madrid.
Yeah, so they was trying to show that they was bad
Yeah.
so they could fight. Be picked.
But
no,
not
not
Ferdinand.
Ferdinand. He
Still
liked to sit
just
quietly
under
under the
court
court tree
And then
Okay,
see him, he's
so,
still in his spot.
Smelling the flowers. I'll say.
one day,
5
5
men
men came in
very
very
funny
friendly
hats
hats to
pick
pick the
biggest,
biggest,
fastest,
fastest,
roughest
roughest
bull
bull to
fight.
fight. In the
Bull
bull fight.
in
In
Madrid.
Madrid.
And you see those 5 men in their big funny hats?
Yeah. They gonna pick you.
This one is fun.
Yeah.
Yeah.
All the other bulls
They ran away.
ran away
Around.
around,
Snorting
snoring
and
and
butting,
budding,
leaping,
leaping and jumping.
so
So the men would
think
think that
they
they were
very
very, very strong and
fierce
fierce
and
and
pick.
pick the
So they put on the show.
Yeah.
Yeah, I'm bad. I ain't gonna what you saying?
Fernand,
Ferdinand
Fernand
knew
Okay, I'm so sad.
that they
wanted
wouldn't pick him and
he
he
didn't
didn't
care.
care. So
Feel sorry for yourself.
he went
Out
out to his
favorite
favorite
court
court tree to
sit.
sit down.
So
Feel
Ferdinand
sorry for yourself.
no, he knew they wanted to pick him and he didn't care.
Okay.
He just went to his favorite court tree.
So I'm thinking is that he's gonna get picked.
Alright, go ahead and turn the page and see if you're right.
What she says.
She thinks he's gonna get picked.
Oh, you think so?
Because lots of times people that don't think they're gonna get picked are getting picked.
Let's find out.
He
Didn't
didn't look
where
where he was
sitting
sitting.
and
And
instead
instead sitting on the
nice,
nice,
cool
cool
grass
grass
in
B.
the
The
shade
shade he sat on a
bumble
Bumble.
bee.
Look at me. Yo, Lord.
let's go
Oh,
with
that's
B.
it. Be scared.
And he's gonna get sting.
Scared him.
He's gonna get
He said,
sting.
uh-huh.
See? He's getting sting. That's why he's hiding like that.
Well,
Well,
if
if
you
you were an a bumble bee and a
bull
bull
sat
sat
on
on
you,
you,
what
what would you do?
What would you do?
You would sting him, and
that
that
He's doing
is
just
what
this
this bee did to
Ferdinand.
Son, look at him. He's so sad.
He's like, what?
Yeah.
Dad's running away because
Wow.
the bee stung him.
Wow,
Is that the bee right there?
that's the B.
That's yeah.
I love to put the bee fly away and
Uh-huh,
run in
here it
circles and
is.
that was the dust.
That's it. That's it. Dust he
Yeah,
kicked up getting out the way.
right here. Wow,
Wow,
did
did it
hurt
hurt?
Wow, did it hurt?
Yes,
Ferdinand
jumped up. What was
No, yes.
with a
snort
snort? He ran
around
around
puffing
puffing
and
and
Oh.
snorting,
snorting
butting
and
and pawing.
This is where they're gonna take it.
Me.
The
Ground
ground
And he was
has
if
if he were
crazy.
crazy. So this is the part he's gonna get picked because he's actually crazy. So let's try to pick him now. The
Oh, that made him. They think he's fast.
the
5
5 men largest and
Fiercest.
fiercest war
Of
of
all.
all.
That'd be
Just
Just the one for the whole
finds
fight in
Madrid.
Madrid.
that made him excited. They thought that he was fast.
And they're putting him in there.
Put him in a cart.
So they
Took
took him away
for
for the whole fight
day.
day. In a cart. In a little cart. That must be squishy.
He did it at the end. Big one.
What a day. It was
Flags
flags were
flying.
flying,
Bands.
then
Bands.
bands
Bands
Play.
were
Play.
were playing.
and then you see everyone on the street is real excited.
Real
Flags are
excited,
flying,
yeah.
bands are playing.
That's a big day, you know.
That buildings are yeah.
Oh, that's how Spain looks.
The building was broken.
He made the day. Made everybody happy.
Other buildings was broken. And all the
Lovely
lovely
ladies
ladies
had
had
yeah
flowers.
flowers.
Flowers. That's it. Say it again.
In
What's the word?
This one.
flowers.
Mhm.
In
There.
there.
Hair.
Had
Hair.
hair.
See?
See? All those lovely ladies with flowers in their hair.
They dressed for the show.
They
You
kind
ready?
of look like people from Japan. They had
A
a
parade
parade into the bull
ring.
ring.
They had parade.
Dangerous. Maybe one of the bulls can
They
break
see
out.
going on. They had
It's dangerous because one of the bulls can break out.
Let's see. Hey, let's see, they had parade.
First.
First came the
And
band
there.
and
And
band there.
we rails.
ladder rails.
Yes.
With
Long.
a long
Sharp.
Make it man.
Pins.
pins. I see no pins.
Right here.
With.
With
Ribbons.
ribbons in
On.
on them
Mm-hmm.
Oh, they
to
gonna be mean now, really.
Stick.
stick in the
Bull.
bowl. The bulls are going to do something to them.
Or make it man.
And
Make.
make them
Him.
him mad.
Oh, they thinking about doing that now.
They're trying to make them mad.
They
Maybe
wanna make
maybe
the
they're
bull
maybe
mad.
they're the bulls gonna crush them.
They wanna stick those pins down. Make it
Maybe
man.
the bulls are gonna crush them.
You might.
Next.
Next
Came.
came the
Hit. Got.
pig.
Doris.
Picadors.
Uh-huh.
They have really long swords. That's really long sticks.
Who?
Who
Rode.
rode
Skinny.
skinny horses? And
Oh,
they would
Hat.
had
Long.
long
Spear.
spears to
Stick.
stick in the holes and make them
Him.
mad.
Matter.
like they being mean, didn't it?
They're
This
trying
is a big bullfight. They gotta get the bull.
I got a lot of money riding on it too, Justin.
Mhm.
after this the bulls are gonna hurt them.
They probably got a lot of money riding on that bull. Betting on it.
Then came the
Matador.
manager
He's the big man.
and
The
the
proudest.
proudest of all.
He
He
thought.
thought
They're proud.
He
he was
very
very
handsome.
handsome and
Bowed.
bowed to the
Ladies.
lady. He
Had
had a
red
red
cape.
cape and a
Sword.
sword and was
Supposed
supposed to
stick
stick the bull
last
last
of.
of all.
So that's That's his red
That
cape.
proud here.
And see, he got his
Red tape.
got his assistant holding his sword.
Yeah. And his red tape on.
He's ready.
Then came the bulls, and the bulls are coming. Then came the bulls, and you
No.
know
Who?
who
That.
that was.
Don't.
Don't you?
You.
Don't you?
Ferdinand.
Do you know good word?
Ferdinand.
There he is. There he is right there. Check it out. That's Ferdinand. Check it out.
They're all getting scared now. They didn't know it was going to be that big. They
Called
called
him
him
Ferdinand.
the
Fierce.
Fierce. And all
The
the
bandereros
banderillas were
afraid
afraid
of
of
him.
him. And the picadores were afraid of him, and the
Matador
matador
Yes.
was
scared.
scared.
Stiff.
Yeah.
And you see them all.
Yeah.
The banderas, the picadores, and the matador. You see how scared they are?
This one is looking scared.
That's the matador.
Yeah, scared him.
Because his eyes is open the mouth. And she's like,
That's scared. Yeah.
Call those bot eyes. Ferdinand.
Ferdinand ran to the
Middle
middle of the
ring.
ring. And
Everyone
everyone
shouted.
shouted,
Everyone shouted.
everyone shouted,
You know that word.
and
Clapped
clapped
because
they
thought
thought he was
going
going to
fight fiercely.
fiercely. And
But
and
snort,
snort and
stick
stick his horn
around.
He come in there and clean up, didn't he?
That's what they think he's gonna do.
Yeah. Old Ferdinand.
Right here.
But
Ferdinand.
What when he got to the
Middle.
middle of the ring, he
Saw.
saw the flowers in
All.
all
Lovely.
lovely
Ladies.
ladies'
Hair.
hair. And he
Just. Sat.
sat and
Quietly.
quietly and
Smell.
Oh my
Cause
God.
y'all know he likes flowers.
Yeah, what a big
Turn the
disappointment.
page.
What a big
everybody's gonna be
disappointment.
mad.
What a big disappointment.
I'm gonna just stick him and so he can get back.
Right here.
He
When he fight.
Wouldn't.
wouldn't fight and be
Fierce.
fierce. On
No.
no
Matter.
matter what
Day.
they
Did.
did, he
Just.
sat
Again.
and
Smell.
smelled and the
Banderas.
bandoliers
Oh,
were
man.
mad and the
Picadores.
pecadores
Man up.
madder
Oh.
and the
Matador.
matador was
So.
mad he could
Cry.
Cry.
cry
Or broke his
Because-
heart.
because he
Couldn't.
couldn't
Show.
show
Oh.
Off.
off
With
with
his
his
cake.
cake and
Sword.
sword.
So you see them all
Yeah.
mad.
Big
'cause
disappointment, wasn't it? They were disappointed. That was a big disappointment.
So
Oh.
they
His butt back in the
had
had to
take
take
Ferdinand
Ferdinand
home.
home.
And that's Bessie got it right here.
in
They're
that
taking it
way.
back home.
And that's a way.
See,
That's the
right
stadium
there,
where he
taking it-
was. Now they taking him
Taking
home.
it back home. Years went then. Oh, yeah. And he took
And
it.
back. And
For
for all
I
I
know
No.
know
He's still sitting there.
is
sitting
sitting
There he is.
there just quiet.
quietly.
He is
Very.
very happy.
Oh, fella. Yes, yeah. That's nice. Ferdinand.
And that was the big poster they had for him.
Mm-hmm. He had himself a bottle.
And
He had
while sitting down.
Mm-hmm.
He was happy while he was sitting down. Like this.
You liked it, girl?
Uh-huh.
You like it, Lyric?
Yeah.
He's just sitting down.
So let's read one more thing about the brain,
Okay.
and then we'll finish up.
And then I can eat my yogurt and drink it.
Yep.
What?
She gonna eat her yogurt and drink her juice.
Oh, we disturbed her. Okay.
Okay, this is neurogenetics.
Oh, okay.
A gene is a set of instructions in DNA for making a protein. There are about 22,000 genes in the human genome.
Mm.
Although proteins are the essential cogs and levers in the functioning of all neurons, no cell needs all 22,000 genes. So neurons, along with other cells, turn on only the genes required for their own needs. As needs change, different genes are turned on or off. This changing pattern of active genes is particularly notable in the functioning of synapses. This is important because changing the connections in neural circuits allows us to learn from experience. Consider a neural circuit that detects a potentially threatening sensory stimulus.
Mm-hmm.
If the threat persists, strengthened circuit connections will be required to sustain and enhance vigilance. To achieve this, signals are dispatched from the sharp end of neurons, the synapses, to their central nuclei, and the DNA is ordered to turn on the required genes. Freshly made synapses reinforcing proteins are then rushed back to the same synapses that ordered them. So while genes certainly affect brain function, the fact that they can be influenced by their environment frees our behavior from a rigid genetic determinism, as the brain's genetic machinery responds adaptively to changing circumstances. Okay, so
That's right.
the brain, some of the big points, the brain uses 70% of our 22,000 genes. Those affecting synaptic function are particularly important because their activity can be regulated by experience. Genes have an important role in disorders of the mind and behavior, such as autism, ADHD, depression, bipolar disorder, and schizophrenia.
Mm-hmm.
In fact, while these are considered as clinically different, recent research suggests that they share genetic risk factors. The identification of shared genetic causes of a range of psychiatric disorders may lead to the discovery of an underlying molecular mechanism for mental illness. This would represent a major advance in the development of preventative medicines. All right. Turn the page there.
That's right.
Yeah.
He plays a big part in about it, doesn't he? Right.
Okay, now we'll learn about this guy. His name is Santiago Ramon E. Cajal.
You see them look right?
Yeah, I'll read it for you. Okay, and on May 1st, 1852, he was born in Petilla de Aragon, Spain, where Ferdinand lives.
Yeah.
In 1873, he graduated from the medical school of the University of Zaragoza. In 1874 through 1875, he served as an army doctor, accompanied expedition to Cuba. In 1883, he was appointed chair to the autonomy of the University of Valencia. In 1888 through 1894, he published Revista Trimestrito de Histologica Normal e Patologia, results of his systematic historical study of the nervous system. In 1888, he discovered that axons terminate freely and the existence of dendritic spines or neural dendricities. In 1891, he promulgated his theory of the individuality of the nerve cell. In 1892, he published his law of dynamic polymerization. In 1901, he was appointed director of the Biological Research Laboratory, which would become the Cajal Institute in 1922. So he did all this. He's not even 50 yet. He's still 49.
Yeah.
In 1906, he shared the Nobel Prize for physiology or medicine with Camille Golgi for their work on the structure of the nervous system. Won the Nobel Prize at 54, Grandma. And then he died. Oh, he died in Madrid. And we know that's where Ferdinand was.
Yes, right.
Remember? He was in Madrid.
What place is that for, Dad?
I think he was there before Ferdinand, man. That was in 1934. So he lived to be 82 years old. You outlived him, Grandma.
All right.
He did a lot, didn't he?
Yes, he did. Smart man.
Alright, so he's why we know so much about the brain. Acknowledged by many to be the architect of modern neurobiology, the young Cajal tried very hard to keep out of medicine altogether. He wanted to be an artist, but his father, a professor of dissection, was equally adamant that he should be a doctor.
Okay, because he did dissections.
After miserable but educational apprenticeships with a cobbler.
I don't think she's on the couch.
Yeah, hold on.
He's going to get through in a few minutes.
I'm just starting to get into intelligence.
Okay.
I want you to open it up.
Cajal gained his my fault. After miserable but educational apprenticeships with a cobbler and a barber, Cajal gained his medical license and buckled down to join the family business, eventually being appointed professor of autonomy at Valencia. He kept up with his drawing, making many autonomous studies and it is possible that it was his artistic eye that led him to his greatest discovery. When in 1887, now at the University of Barcelona, he looked at the Italian physician Camillo Golgi's immaculately stained slides of brain cells. He saw what others had not. Until this time, the prevailing orthodoxy was that the nervous system was a single rectangular mesh-like construct without discrete cellular components, neurons. Kagil realized, however, that what Golgi's images clearly showed was that the nervous system was a network of discrete cellular components. This was a correct interpretation that crucially allowed neurons to be regarded as the functional units of the brain, free agents that could form many synaptic connections, each capable of being modified to allow for growth and adaptation. Kagil studied this newly revealed phenomenon for 4 years, identifying as well so-called dendritic spines, small membranes, prostructions from a neuron's input fibers that typically receive input from a single synapse. He used his artistic skills to make meticulous drawings and then publish his findings in his magnum opus, the Revista Trimestro de Historia Normal e Patologia, which had an impact on the scientific community similar to Darwin's breakthrough on the origin of species. They're saying it's as important when Darwin came out with natural selection.
Yeah.
By providing the most accurate description of the neuron's function and mechanism, it changed the way neuroscience worked and cleared the path for the formulation of neuron doctrine proposed by German autonomist Hendrik von Weider-Hartz. Kagil was a prodigious publisher and contributor to medical journals. He was greatly feted and heaped with awards, including the 1906 Nobel Prize for physiology or medicine,
He was smart man.
which he shared with Golgi. Kagil also found time to work in other areas of medicine, notably cancer, and to set up his own research institute in Madrid, where Ferdinand lives. For all the breadth of his achievements, he will always be best remembered for distangling the neuron from its imagined network.
Wow. So what you want to eat, you this year? What you want to eat that?
And then downstairs on the desk.
Okay.
We'll go over there and eat it.
All right. So,
You're getting nervous.
well,
Get that on my mind.
okay. There's. You can go eat that. Grandma, I'm gonna read you the basic architecture of the brain.
Oh, yes.
Okay. The 30-second neuroscience. Imagine you just picked up. You need a paper towel there? No? Okay. Imagine you just picked up a typical 3-pound a 3-pound adult human brain. The outer spongy tissue that you grip in each hand is the cortex. Look at the apparently random patterns of grooves on the surface. The slushy, and you'll see some deeper lines. These landmarks show the divisions between the main lobes of the cortex, the frontal lobes, and the temporal lobes near the ears. the parietal lobe at the crown of the head, and the optical lobe at the rear. Lift the brain above your head, and spouting underneath, you'll see the brain stem, responsible for regulating the most basic life-sustaining functions, including breathing and heart rate. Also note the cauliflower-like cerebellum nestled next door in a living person. The brain stem would connect to the spinal cord, thereby linking the brain with the rest of the body. Now place the brain back down and gently pry apart the two hemispheres so that you reveal the inner structures, including the top of the brain stem, known as the midbrain. Above this is the egg-shaped thalamus, the brain's relay station. Nearly all incoming sensory information is sent here before being passed on to the cortex. In the traditional language of anatomy, the brain stem is the metencephalon. The thalamus is part of the disenseptalon, and the outer cortex is the teleseptalon. Wow. Okay.
That's the brain.
The brain can be divided crudely into three basic parts: the outer cortex, the diseptalon, including the thalamus, and the brain stem. And we can see these three right here. We now take it for granted that the brain is the seat of thought, but this wasn't always the case. Even after the importance of the brain was demonstrated by Galen in the 2nd century CE, Common Era, it would take more than a millennium for this view to be universally accepted. Writing as late as the 17th century, the English philosopher Henry Moore argued the human brain has as much potential for thought as a bowl of curds. They didn't think the brain used to be worth anything.
Sure didn't.
How about that?
Wow.
And look at it.
That's what I'm looking at. The brain, and they've been studying the brain
For a long time. Okay. The cerebellum. Hanging off the back of the brain is a second little brain. The literal translation of cerebellum. Oh, you can see it right here. Resembling a fist-sized cauliflower, densely packed with cells. It accounts for 10% of the brain's volume, and yet contains around half the neurons found in the entire central nervous system, like the big brain. Hey, you finished? Okay, can you hold the book? All right, so I'll restart. Hanging off the brain is the second little brain, the literal translation of cerebellum. So you see that right there? You see it there, the blue part?
That's the brain. That's the back of his
That's the cerebellum. That's the brain.
Uh-huh.
And that right there is the cerebellum, the little part. Resembling a fist-sized cauliflower, densely packed with cells, it accounts for 10% of the brain's volume, and yet contains around half the neurons found in the entire central nervous system. Like the big brain, the cerebellum is comprised of two hemispheres, except here they are joined by a narrow structure known as the vermis, literally worm. Further in common with the cerebral cortex, the highly convoluted cerebellar cortex is made up of white matter in its deeper parts, with gray matter nearer the surface. The cerebellum contains many intricately branched Purkinje cells, which are found only in this brain structure. Since at least the early 19th century, neuroscientists have recognized the important role played by the cerebellum in the control of movement and posture. Abnormalities in its function, whether caused by inherent disease, brain damage, or the effect of alcohol, lead to difficulties in walking and a general clumsiness to movement. In recent years, our understanding of the cerebellum has undergone a revolution, and it is now thought to be involved not just in motor control, but in memory, mood, language, and attention.
Brains be a party, all that.
Wow. Look at all that. You see the dancers?
Yeah.
They're doing all that because of the cerebellum.
All the brains.
The cerebellum or little brain is densely packed with neurons, and its primary function is in motor control and coordination, although we now know it does much more. The cerebellum is responsible for the fact that we are unable to tickle ourselves. Huh?
Somebody else have to take.
Yeah, that's because the cerebellum, as well as calculating the movements necessary to achieve a desired action, known as inverse model. Another of the cerebellum's role is to form predictions, forward models, of the probable sensory consequences of our own actions and to cancel them out. Self-tickling doesn't work because of this process.
How
Why
about
are you
that?
trying to tickle it so hard that I know it?
Huh?
I'm trying to tickle it so hard that I
Oh,
know it.
you're just trying to see if it. No,
I
the
never thought of that.
cerebellum won't let it happen.
I never knew that.
No,
But
because
you can tickle somebody
you can
else.
tickle someone else and not just
You can
giggle.
tickle,
Turn the page with.
but you can't tickle yourself.
How about that?
That's boring.
That's the brain. The developing brain. The brain develops from a hollow tube formed from the skin of the very early embryo. Cells multiply more rapidly at the front of the tube, which enlarges, becoming the embryonic brain. Newly produced cells transform into immature neurons. By the time the embryo is about 4 weeks old, these migrate to their destinations, growing dendrites and axons and forming the first of what will be trillions of synaptic connections. There is no blueprint for these interconnections. The embryonic brain generates an excess of neurons and synapses, allowing competition and interactions with the environment to scope functional circuits. About half of the embryonic neurons are killed off, having failed to form useful connections. Some surviving neurons involved in transmitting information over long distances have their axons insulated by glial cells, a process called malathion, which increases the speed and quality of information transmission. Until recently, brain development was thought to be completed in early childhood. In fact, gray matter volume increases gradually through childhood, peaks in early adolescence, and shrinks as adolescents become an adult. This reduction in brain volume seems odd, but reflects the brain's ability to adapt to the environment by by pruning unused synapses and strengthening useful ones. Huh.
How about that?
So that all the things that you use in your brain, they get stronger, and all the ones you don't use, they get weaker. That's what they mean when they say use it or lose it.
Sure did.
Remember that?
That's right.
Use it or lose it.
That's the truth.
How about that? The properties of the brain are maintained by dynamic plastic mechanisms that originate in the embryo but continue to operate after birth and into adulthood.
That sure is the truth. If you sit around, don't do nothing, you don't interact with nobody or nothing, your brain just get dumb. You become dumb.
Yeah. It's weird. And then the more you use your brain,
smarter you get.
how about that? Brain development is characterized by a convergence of genetic, nature, and environmental nurture influence. A misunderstanding of the interaction between them lies behind questions such as, is this or that trait due to nature or nurture? But it is wrong to present the question as an either or proposition. The genome does not contain enough information to make a brain on its own. So genes have evolved to exploit information coming from the environment.
Yeah.
Information essential for fine-tuning developing neuronal networks.
I mean, what we just said about the environment.
Yeah, it's not just who your parents are.
Yeah.
It's also where you live.
In your environment.
Yeah.
Or you sit around there, like person sit all day and don't even integrate with other people. They dumb.
Yeah.
You ain't learning that.
I guess if you was around a whole bunch of hunters, you would know how to hunt. But if you were around a whole bunch of math professors, you would be really good at math.
That's right. It makes sense too.
Yeah. All right. Well, we lost our little we lost our light. It's gotten dark outside. All right. So I guess we'll stop for today.
What made you think about this?
Oh, well, you chose the brain, Grandma. I remember I had all the books out, and I didn't know what you were gonna pick.
What made you think about teaching us?
I thought that.
That was just wonderful.
So we know so much more about the brain.
Yes.
Oh, I bought them from Barnes and Nobles.
Ah.
Yeah, got a whole lot of books.
Yeah, really books, huh?
Okay, so we read Ferdinand.
We finished
We finished Ferdinand. If you missed it, we'll read it again next time. And we also read The Brain. I put a bookmark where we are in The
That was a
Brain.
good subject too.
All right.
That was a good subject, the brains.
Hope you all enjoyed.
I enjoyed it.
I called it Reading Chair.
Yeah, thank you so much.
All right, Grandma. Lyric. Tell them. Botsy out. Botsy out. That's how we end.
Oh.
Yeah, you say
Okay.
Botsy out.
Botsy out.
Botsy out. Botsy out.
That's good.
All right.
Thank you for coming and taking that time with old lady. That's wonderful.